All right, welcome back. We're going to talk a little bit about the unit circle um, and its some of its relationships. And today we're going to talk just about the equation and the role that it plays in defining it. So the unit circle is a circle of radius 1 centered at the origin, i.e. 0, 0. So it's centered here at the origin on the Cartesian coordinate system, right? And it has a radius of 1. So there's the radius right there. And you can see one point right there, 1, 0. All points satisfy this equation. So if I plug in a 1 and a 0, we all know that 1 squared is 1 plus 0 squared is 0, so 1 equals 1, and that satisfies that equation. And we can continue all the way around the circle. We can do all the easy ones. So it doesn't matter whether I plug in that 1 for y or for x, but it's going to work. And even when 1 is negative, because negative 1 squared is also positive 1, so that works. And that's true for all points, so including that one down there. Let's zoom in a little bit and look at some more points. Now, one of the points along here, you'll notice that the x and y are equal. They both say 0.71, 0.71. Not sure if you can see that or not. But let's think about that for a second. If x squared plus y squared, if x equals y, then x squared plus y squared equals 1, our equation of the circle, then really what that's saying is x squared plus x squared equals 1. Hey, we can simplify that a little bit into 2x squared equals 1. X squared equals 1/2. Take my square root, and then I can do some stuff with the with that. We know the square root of 1 is 1, and the square root of 2 is just square root of 2. But in general, we don't like to have radicals in the denominator, so we're going to rationalize that by multiplying by root 2 over root 2. And then you'll get 1 times root 2 is root 2. Root 2 times root 2 is just 2. And so then we get square root of 2 over 2. And since x and y are equivalent, we get this point right here. Root 2, comma, root 2 over 2, comma, root 2 over 2. So that's one point. Now, you'll notice that I put these divisions in at 1/2, right? Well, let's see what happens when I plug in, when I take x equals 1/2. So I plug it in here. 1/2 squared is 1/4. Subtract 1/4 from both sides. And then I have to add fractions, so I need a common denominator. And I get y squared equals 3/4. And then I take my square root. And square root of 3 is just the square root of 3. Square root of 4 is just 2. And so I get square root of 3 over 2. So I plugged in 1/2 for x, and I got out root 3 over 2. So that's that point right there. This process seems familiar. If this process seems familiar, it is. It's the good old Pythagorean theorem. X squared plus y squared equals r squared, or c squared. And it's all based around this idea of right triangles, right? Where you have and if you think about each coordinate of a point, right, the x-coordinate is the base, and the y-coordinate is the height of your triangle. Let's flip that triangle on its side and say that y equals 1/2. So once again, if I plug that in, I'm going to end up with the same coordinate, or the same other side. So in this case, my height is 1/2, and my base is root 3 over 2. Now, these relationships repeat themselves all around the circle. Okay, you can see the 1s and 0s at all kind of the north, south, east, and west coordinates where it intersects the axes. You can see the 1/2s in the y-coordinate and the 1/2s in the x-coordinate. And then these ones are always the same. The only thing that changes is the sign. So in the first coordinate, both of them are positive. Second coordinate, negative, positive. Third coordinate, both coordinates are negative, negative, negative. And in the fourth quadrant, the x-coordinate is positive and the y-coordinate is negative. Pretty intuitive. But we're going to see these values over and over and over again. You need to memorize them. These are listed in order from smallest at 0 to greatest at positive 1 and 1/2. And as you look at this, right, we know that the square root of 2 is greater than 1. So root 2 over 2 is bigger than 1/2. And root 3, square root of 3, is going to be bigger than the square root of 2. So that means that these are all listed in order. And that's kind of important when we start thinking about it for helping you memorize it and getting the patterns down. So here are some patterns to help. They come in pairs. 0 and 1 are always together. 1/2 and root 3 over 2 are always together. It's just sometimes the x-coordinate is 1/2 and sometimes the y-coordinate is 1/2. And then root 2 always goes with root 2 over 2. Kind of like this. Now, another pattern that helps that I think about is the zeros and ones are easy, but if you look at these triangles, you can see that in this case, the y-coordinate is smaller than the x-coordinate, right? And so that means that the 1/2 is going to be the y-coordinate, and the x-coordinate is going to be root 3 over 2 because it's bigger. In this case, the y-coordinate is larger than the x-coordinate, and so this is going to be root 3 over 2, and this is going to be 1/2. Then when the x and y coordinates are the same, they're root 2 over 2. So what I want you guys to do right now is write down the unit circle in your journal, or you can print out the copy that I've attached on the page. And then I want you to fill in all the coordinate points. Don't worry about the angles for now. Just like this. I just want you to fill out these outside points all the way around and think about which ones are negative and positive, which ones are x's and y's. So take a minute and stop. Take a minute and try and fill all those out.